Hello ladies and gentlemen, last video for today. We're going to do 5.9, writing polynomial functions. Our objectives are to write higher degree polynomial functions using a method that we used when we did quadratics. And then we're going to learn a new method to determine what degree of regression analysis to do on your grapher. So I will go through the regression several times as we walk through examples in today's notes. So our lecture is a little bit longer today just because we have some calculator work to do. Alright, so let's start with our first example, and let's say you're given a graph of a polynomial and it is something that looks kind of like this. I know that this 0 is a -4. This point is 0, -6, so that's your y-intercept. This value is 1, and this x-intercept is 3. So if I want to write an equation for this function, so it's going to be write the model for the cubic function. I'm going to start using the form f of x is equal to a times x minus a factor and x minus another factor and x minus another factor, since we have a cubic polynomial. Alright, so I'm going to substitute in what I know. So I know that f of x is equal to a. I don't know my a. I'm going to have x plus 4, x minus 1, and x minus 3. Now I'm going to substitute in the point that they gave us, the 0, -6, and I'm going to use that to solve for a. So the y value is a -6, and it's going to equal 0 plus 4, 0 minus 1, 0 minus 3. Okay? So if I multiply those together, I get a -6 is equal to a times 12. So a is equal to a -6 divided by 12, which is a -1/2. And now I can go ahead and finish writing the equation for my polynomial, and I would say f of x is equal to a -1/2, that's the a value, and then I'm going to leave this one in factored form, because unless they tell you to put it in standard form, you can leave it in factored form, and this would be the model for that particular cubic function. Alright, so now let's go back and do a regression problem. So the next example is going to say write a cubic function. So they're telling you what type of model to use for the graph that passes through the given points. So basically what they're going to do is give us a set of data, and then we're going to do cubic regression on that data, and I will walk you back through that process. So I'm going to do my chart sideways just because. So I'm going to have a -4, 0, a 0, 10, a 2, 0, and a 5, 0. Alright, so those are going to be my values. So now let me bring in my grapher, get it where I hope where you can see it. Okay, that's from previous information. Alright, so the first thing that I do is I go into my memory and I clear the memory so I can have a fresh start. I'm going to go to stat and I'm going to edit and I'm going to enter my data. So I have a -4, 0, 2, and 5. Then I'm going to enter my y values. I have a 0, 10, a 0, and a 0. Okay? We're not predicting on these, but just writing the equation. So now I'm going to do stat, calculate. They told us in the problem that this was a cubic regression, so I'm going to hit enter. I'm going to show you how to enter it in case you don't have, or if you have your lists in a different table. So I would do second L1, comma, second L2. Those happen to be the defaults for your calculator, which is why I never do it. But sometimes we have data living in different lists. So when I hit enter, now there's my equation. And I'm going to scoot this over so now you can't see the data. But my generic equation is y is equal to ax cubed plus bx squared plus cx plus d. You may not leave it like that. You have to substitute in the values. So your solution would be y is equal to 0.25 x cubed minus a 0.75 x squared minus 4.5 x and then plus 10. It's okay if your calculator doesn't show you an R value. Later in the year we'll talk about what that R value means, but for right now it's not necessary. And then this would be your final solution, and that is going back and doing the regression analysis again. All right, so now as we move on to the next problem, what if the situation changes a little bit? So what if I'm given a set of data? So I'm going to write I'm given a set of data, but I don't know the degree. So instead of doing a trial and error process with regression, I'm going to do a process called Finite Differences. So that's the name of the method that we're going to use. That method will tell us what degree. So the purpose of this is to tell us what degree, and then we will finish by doing our regression. Okay? All right. And I'm going to show it to you a couple of different ways. I do the math a little bit differently than the book, but I'll show it to you both ways. So here's going to be your data. I'm going to do it in a vertical table. And I think my x values are 1, 2, 3, 4, 5, 6, and 7. And then my y values are 1, 4, 10, 20, 35, 56, and 84. So here's the way the finite differences works. I think it'll be easiest to show you an example. So first I'm going to subtract. I'm going to do 4 minus 1, and I'm going to get 3. 10 minus 4, and I'm going to get 6. 20 minus 10, and I get 10. 35 minus 20, and I get 15. 56 minus 35, I get 21. And 84 minus 56, and I get 28. If all of those numbers had matched, then I would know that that's a first degree polynomial. But all those numbers did not match, so we're going to do it again. So I'm going to do 6 minus 3, and I'm going to get 3. 10 minus 6, and I get 4. 15 minus 10, and I get, 5. 21 minus 15, I get 6. And 28 minus 21, I get 7. That particular column of numbers doesn't match yet, so now I need to do it one more time. So I'm going to, hopefully one more time. I'm going to subtract 4 from 3 to get 1. 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. That tells me, because all of these numbers are the same, and they don't all have to be ones, but they all do have to be the same number, that tells me that we need to do cubic regression, because that tells me that my data is a third order data, which means basically that it's a third degree, because it was 3 steps to get to numbers that match. So now what I'm going to do, I'm going to clear my memory, and I'm going to go into stat, and I'm going to edit, and I'm going to enter my x values first. So I had 1, 2, 3, 4, 5, 6, 7, and then I'm going to enter my y's, 1, 4, 10, 20, 35, 56, and 84. And now what I'm going to do is I'm going to do my stat, calculate. We found out by using the finite differences that it's a cubic model. And there is my cubic model. So I'm going to cover up my data. So my model is y is equal to 0.167x cubed plus 0.5x squared plus 0.333x plus, and then I have a 0 for the d, so I really don't have to write that. And so now I have a cubic model for my data. And even though I didn't know what type of model to use, by using finite differences, that told me which model to use. So that's a pretty cool process. Finite differences can also be used in a slightly different manner, but we're not going to do that since we haven't studied matrices yet. All right, so let's do the next example, and I'm going to manage the math a little bit differently. I typically do mine this way. I like the vertical arrangement better, but I'll show you how the book does it. All right, so let's say this time I'm going to have the same directions, so I'm going to use a combination of finite differences and regression to write a model for the data. So here's going to be my x's and my y's. This time I'm going to do horizontal data. I have 1, 6, then I have 2, 15, 3, 22, 4, 21, 5, and 6, and 6, and a negative 29. So the way that your book does the math, I'll just draw a line right there, so that's the bottom of our table, is they do what I did up above kind of underneath. Now they would do 15 minus 6, and they would get 9, 22 minus 15, and I would get 7, 21 minus 22, and I would get a negative 1, 6 minus 21, and I get a negative 15, and a negative 29, and a negative 6 is a negative 35. So when you start having a broader spectrum of numbers, you do have to be careful with your negatives. So this was a negative 29 minus 6, which gave me the negative 35. And that's a first degree. That would be linear. Obviously, that doesn't work. So now I'm going to do the other ones. 7 minus 9 is a negative 2. A negative 1 and a negative 7 is a negative 8. A negative 15 and a positive 1 is a negative 14. And a negative 35 and a positive 15 is a negative 20. There's a second degree. And the numbers still don't all match. So now I'm going to do it one more time. A negative 8 minus a minus 2, which is what I've been doing all along, so it's a negative 8 plus 2, is going to be a negative 6. A negative 14 plus 8 is a negative 6, and a negative 20 plus 14 is a negative 6. Now they all match, so now I know that this is a third degree polynomial. All right, so let me bring my grapher back in. Hopefully you can see it. It's a little dark. Okay, maybe, there we go. Maybe that's better. So now I'm going to clear my memory. I'm going to go put my data in. Okay, and I always do my x's first. 1, 2, 3, 4, 5, 6. And then I put in my y's. 6, 15, 22, 21, 6, and a negative 29. And then I'm going to do, we decided it was a third degree, so I'm going to do stat, calculate, 6 for cubic regression, enter. And there's my handy dandy formula. So I'm going to cover up my data so you can see my calculator. I'm going to write the model to be y is equal to a negative 1x cubed plus 5x squared plus 1x and then plus 1. And that's the d. So sorry I had to go on the second line. And that's your model. So it's really kind of a cool process. Alrighty. I'll do one more example for you just to make sure we have the hang of it. And then we'll move on to do your problems. So really not a very long video. Alright, last example. Yeehaw. Alright, again the directions are going to be use a combination of finite differences and our regression analysis to write a model for the data. Alrighty, so now let's get our table. I'm going to go back and do the vertical. I don't know why, but I just like the way the vertical looks better. So that's the way I'm going to structure my data. I don't care how you do yours. You can rewrite it either in a vertical or horizontal manner, whichever makes you happier. Have a little hot chocolate break. Alright, so my data for my x's is going to be a 1, a 2, a 3, 4, 5, and 6. My y's are 0, -3, -8, -15, -24, and a -35. That's a lot of negative numbers. Alright, and then I'll start doing my finite differences. So a -3 and 0 is obviously going to be a -3. And I'm going to write this one out just to make sure you know what I'm doing. I'm going to do a -8 minus a -3, which is a -8 plus 3, and that's going to be a -5. There's my equal, sorry. And then if I do a -15 and a +8, I get a -7. A -24 and a -15, I get a -9. And a -35 and a +24, I get a -11. That's our first degree. They obviously don't match. So now I'm going to do the next row. A -5 minus a -3 is a -2. A -7 and a -5 is a -2. I have a -2, and I have a -2. Well, that was very polite. Now I have a second degree polynomial. Bring in my grapher. I think you can still see the data. So clear the memory. Let's enter our data. Okay, so I have 1, 2, 3, 4, 5, and 6. And then a 0, -3, -8, -15, -24, and -35. There's my data. I always give it a quick look to make sure I didn't enter anything badly, because if you do, then everything's going to be off. Then I'm going to do stat, calculate, and then I'm going to do option number 5 this time for quadratic regression, because we found out it was a second degree polynomial. And there's my equation. So notice that it looks a little bit weird. I'm going to write the generic model up here. So it's ax squared plus bx plus c. When I substitute in my values, I get a -1 x squared plus, well, this is a weird number. This is a -2.7 times 10 to the -12, which basically means that's 0. So I'm going to write 0x and then plus 1. Okay? Alrighty, so then if I simplify that equation, I get a -1 x squared plus 1 because the b term went away. And there's my model. So that's pretty cool. Alright, so let's go back and just remember what some of our regression names are. So if I do a quadratic regression, that's a second degree. If I do a cubic regression, that's a third degree. And if I do a quartic regression, that is a fourth degree. So just a couple of words to make sure that you remember. All right, so now let me give you your problems because your lecture is kind of done. That was nice. It was very short. All right, here are your problems. The first set says write the cubic function whose graph is given. Remember when you do these that you will need to find A using one of the additional points. Okay, so your first graph here's the graph, and it's going to look kind of like this. I know that that x-intercept is a -4. This x-intercept is a -1. This x-intercept is a +1. And the y-intercept is a 0, 4/3. Okay, so you're going to use that point to help you find A. Then here is your second problem. Okay, let me give you your graph. Same basic idea. Now our graph is going to go the other way. Okay. Well, I guess it goes the same way. Sorry. All right, this one is a -1. This is a 2, and this is a 3, and this point is a 0, -12. Well, that part's kind of going a different way. My end behavior is still the same. All right, so those are your first two problems. Now what I'm going to do is turn the page, and I'm going to give you the data for your next two problems. So the next two say, use a combination of finite differences and regression. Again, there is another way to do this, but we have not done matrices yet, so that makes that other method difficult. To write a model for the data. So I'm going to give you two different sets of data. So you'll do two different sets of finite differences. So here's your third problem. And I'm going to give you your data this time in a horizontal format. So this is a -2, -18. You can rewrite it in whichever format you like. -1, -7, 0, 0, that's a nice point. 1, 3, 2, 2, and then your last data point is 3, -3. All right, so that's your first set of data. And then let me give you the second set of data. Number 4, so I'm going to do it in a horizontal manner for this one also. And then you can decide if you like to do the math in a horizontal fashion or in a vertical fashion. So this is 1, -12, 2, -14, 3, -10, 4, 6, 5, 40, and then 6, 98. Alrighty, good luck doing your finite differences and your regression, and I will see you tomorrow.